In this video, we'll be looking at all the important formulas and important questions for geometry. As people know, geometry is a very important topic for CAT. So we have released a geometry capsule. The capsule contains all the important tips and formulas for geometry, as well as around 50 questions with video solutions. If you want to watch the video solution, you have to just click on a button that is there around the question. We'll come to it, but first I would start with the formulas. So let us go through all the formulas. We'll look at the important formulas, and the formulas which I feel are not super important, we'll just discuss them in brief. So I think initially we should go through what is geometry. Geometry is one of the most important topics, and there will be a lot of formulas in geometry. I would recommend you to go through all the formulas and try to understand most of them. But more important than just understanding the formulas is knowing how to apply those formulas. Now, to get that confidence of actually applying a formula, you have to solve questions. So try to find out nice questions where you can actually use the formulas that you have learned. Let us go to the next slide. Knowing a formula and knowing when to apply are two different abilities. This, I think, many people just mug up a formula and feel that they know the formula. But the important aspect is knowing when to apply this formula. So we have actually made this document. I would definitely recommend you to download it. This document, you can easily find it in the description of this video. So go through it, download that document, that PDF, and you will be able to get the list of all these formulas, which will come in the next slides, and try to understand each one of them. If you're looking for formulas in other topics, you can just Google search. Let me do that. You can just Google search CAT formula PDF, and if you click on it, then you're going to get our formula PDFs. You can go through you can download all the important formulas according to topic. You have geometry and mensuration, which we have just downloaded now, time, speed and distance. So according to each of the topics we have categorized, you can click on each one of them, you'll get the PDFs for each of these topics. Download all the formulas, they'll help you quite a lot. Anyway, coming back to geometry. The next tip I would have is basically the concepts. Now, one of the first things geometry is, we'll be looking at coordinate geometry, and one of the basic things in coordinate geometry is understanding the four quadrants. If you have the x-axis and the y-axis, they intersect at the origin, which is this point, and so the entire plane is divided into four quadrants. This is the first quadrant, this is the second quadrant, third quadrant and fourth quadrant. Having an idea about in which quadrant is the x-axis positive and in which quadrant is the x-axis negative, and same is the case with y-axis, is an important concept that you will understand by looking at the table over here. Let us go through the next one. There are two concepts in geometry, which is collinear and concurrent. This is also useful when you are solving some questions in permutations and combinations, because many times it is given that there are, like, say 20 points, out of which 5 of them are collinear, and how many triangles can be formed out of it. These kind of questions are often asked. So understanding what exactly collinearity means and what exactly congruency means is also important. Collinearity is basically if all the points are on a straight line, you get a collinear set of points. And you can't form a triangle when the points are collinear. You can form a triangle only if the 3 points don't lie on a straight line. For example, these 3 points don't lie on a straight line, so you can form a triangle. But if, say, like these 3 points, A, B and C, because they are lying on a straight line, they are called collinear points, and you cannot draw any triangle using these 3 points. Concurrent lines, on the other hand, will be if all the lines are passing through the same point, that point over here. So these lines are called concurrent lines. Let us look at the next tip. Next, if you are looking at coordinate geometry, one of the important basic formulas in coordinate geometry is knowing the distance between 2 points. If you are given 2 points, x1 and y1 and x2, y2, the distance between these 2 points is square root of x2 minus x1 whole square plus y2 minus y1 whole square. When you read this formula, one of the things that you should do just as a basic thing is try to find out the distance between any 2 points. Suppose you have a point which is 1, 2 and another point which is 3, 4. Then the distance between them will be square root of 3 minus 1 is 2 square plus 4 minus 2 is again 2 square. This is basically equal to square root of 4 plus 4, which is 2 root 2. Similarly, another very important topic or very important concept in coordinate geometry is slope of a line. Every line in coordinate geometry has a slope. That slope essentially indicates what is the angle which it makes with respect to the x-axis. So suppose you have the y-axis over here and the x-axis. This angle over here represents the slope of the line. Tan of that angle represents the slope of the line. The higher the slope of the line, the more perpendicular it is. The lower the slope of the line, the increase will be more gradual. Now, if you are given 2 points on this line, if you are given 2 points, you can always form a line out of these 2 points, a unique line out of these 2 points, and that line will have a slope. The slope can be formed using the formula y2 minus y1 divided by x2 minus x1. Again, if you are looking at our earlier example of the 2 points being 1, 2 and 3, 4, the slope of the line joining these 2 points will be 4 minus 2, which is equal to 2, divided by 3 minus 1, which is again equal to 2, which is equal to 1. So the slope of the line is equal to 1. Now, when you are given the slope of the line, you can easily form the equation of the line. How can you form the equation of the line? Every line is represented as y is equal to mx plus c, where m is the slope of the line. So in this particular case, the line joining the 2 points will be of the form y is equal to, because the slope is equal to 1, x plus c. We can calculate the value of c by substituting any one of the 2 points. If you are substituting the first point, the y coordinate is 2 and the x coordinate is 1. So the equation of the line will be y is equal to x plus 1. If you substitute the second point also, you will get the same equation for the line. This is how you simply and very easily calculate the slope of the line and the equation of the line if you are given the 2 points. Midpoint of 2 points A and B is x1 plus x2 by 2, y1 plus y2 by 2. That is the average of both the x coordinate and the y coordinate. Now, 2 lines are parallel when their slopes are equal. We have found out the equation of the line joining these 2 points. If you have another line, and if the slope of the line is, instead of y is equal to x plus 1, if it is of the form y is equal to x plus 3. The slope of this line, which is the coefficient of x, is also equal to 1. The only difference is the constant term. So both of these lines, y is equal to x plus 3 and y is equal to x plus 1, are parallel lines. Now when 2 lines are perpendicular, their slopes, the product of their slopes will be minus 1. Again, if you are looking at the first equation, which is y is equal to x plus 1, the slope of that line is 1. So for a line which is perpendicular to it, the slope will be equal to minus 1, because you want the product of their slopes to be equal to minus 1. So that line will be of the form y is equal to minus x plus some constant. It can be any constant, for example say 2. These 2 lines are perpendicular to each other. Let us now look at the next step. Now if you are given 2 lines, we can calculate the angle between these 2 lines by just looking at the slopes. That formula is given over here. You can remember this formula. Another very important formula is, if you are given a point and a line, what is the distance between the point and the line? So for example, if you have the y-axis, x-axis, you have the equation of the line is given. That is ax plus by is equal to c. And you are given a point over here. Now what is the distance of this point from this line? This perpendicular distance can be calculated using this formula. You just substitute the value of the point, the coordinates of the point, in the equation of the line, and then you divide it by the square root of a square plus b square, that is the squares of the coefficients of x and y, and you are going to get the perpendicular distance of a point from a line. This is an important formula in coordinate geometry. You would definitely do well to remember it. Now, what is the distance between 2 parallel lines? Like in the earlier slide, we have looked at 2 parallel lines, which is y is equal to x plus 3 and y is equal to x plus 1. These 2 are parallel lines. What is the distance between these 2? You just subtract the constant terms. In this particular case, it will be 2, and you divide it by the square of the coefficient of x square and y square. The coefficients of x square and y square in both the cases is 1. So this will be equal to 2. So the distance between these 2 lines is square root of 2. This also is an important formula, and it's an easy formula. So again, you would do it to remember it. Actually, the link to download all the formulas is given actually in the footer of this PDF. So you can definitely use it. I would recommend you to bookmark it, because this will be very, very useful for you. You have to just click on it and the page is going to open. This is the same page that we have seen earlier. Go to that page, download all the PDFs. They will help you quite a lot in your preparation for CAT and other MBA exams. Let us now look at the next slide. Similarly, if you are given 2 points, A, which is x1, y1, and B, x2, y2, we can figure out the point which divides these 2 points, the line joining these 2 points in a particular ratio. That is, if you have point A over here, and if you have point B over here, and if you're looking for the point in the middle, which is C, which divides them in the ratio m is to n, you can use this formula to figure out the coordinates of the point C. This is if C is dividing them internally. If C is dividing them externally, that is if C is on the other side of B, then you use the second formula to calculate the coordinates of C. Similarly, if you are given the vertices A, B and C of a triangle, which is x1, y1, y1, x2, y2 and x3, y3, we can calculate the centroid of the triangle, which is just the arithmetic mean of all the coordinates, and we can also calculate the incenter. To calculate the incenter, we have to first calculate the lengths of the sides A, B and C. How are we actually going to calculate the lengths of the sides A, B and C? Using the distance between the points B and C, we will get the length of the side A. If you calculate the distance between the points A and B, we will get the length of the side C. And similarly, if you calculate the distance between A and C, we will get the length of the side B. So we have to first calculate the lengths of A, B and C and then use them in the formulae to get the incenter of the triangle. This is not so often asked, but centroid is an important formula. It can be asked many times. Let us now look at the next slide. This is the equations of a line. We have already discussed them earlier. One way to look at the equation of the line is ax plus by is equal to c. This is something like, say, 2x plus 3y is equal to 4. Another way is y is equal to mx plus c. This is a very common way of using it, and in my opinion, if you transform any equation into the form y is equal to mx plus c, it becomes much easier to actually understand the line also, because if you are getting another line which is parallel to it, many of the things become apparent when you transform the equation to its simplest form. You can transform the first equation 2x plus 3y is equal to 4 into the other form by converting this to equal y is equal to minus 2 by 3x plus 4 by 3. Here the slope of the line is minus 2 by 3. Similarly, there are some other ways in which you can calculate the length, the equation of the line. Let us now look at the next slide. Now, if you are looking at circles, if you have a circle which is something like this, if the center of the circle is, if the coordinates of the circle are a comma b, and if the radius of this circle is, say, capital R, then the equation of this circle will be x minus a whole square plus y minus b whole square is equal to r square. That is the equation of this line. Another way of looking at it is, if you are given a equation which is of the form x square plus y square plus 2gx plus 2fy plus c is equal to 0, you can transform this to something along these lines by completing the perfect squares, and you will figure out that the center of the circle is minus g comma minus f, and the radius of the circle is g square plus f square minus c. It is quite easy to actually transform it. You add g square plus f square minus c to both sides. So the left hand side becomes x plus g whole square plus y plus f plus y whole square is equal to g square plus f square minus c. Now this is very similar to the equation that we first wrote. So you can calculate the center of the circle, which will be minus g comma minus f, and the radius of the circle, which will be square root of g square plus f square minus c. Similarly, if origin is the center of the circle, we are just replacing a and b with 0. It will be of the form x square plus y square is equal to r square. Let us now look at the next slide. This is very important. If you have two angles which are summing up to 90 degrees, they are called complementary angles. If they are summing up to 180 degrees, they are called supplementary angles. And if you have two lines, two straight lines which intersect, then the opposite angles will be the same. That is, if this is A, then this angle also will be A. Similarly, the adjacent angles will sum up to 180 degrees. That is, this angle will be B, then the value of A plus B is equal to 180 degrees. Another corollary to this is that if many lines intersect, then the sum of all the angles which are formed around that single point of intersection will sum up to 360 degrees. That is, if you have three lines which are intersecting. you have 6 angles, 1, 2, 3, 4, 5 and 6. The sum of these 6 angles will be equal to 360 degrees. That is basically the angle around a point. Let us now look at the next slide. Another very important concept in geometry is parallel lines. Here if you are having 3 parallel lines, AB, BD and DF, any line which is intersecting all the parallel lines is called a transversal. Here XY is a transversal and MN is a transversal. Now the angles that are so formed will be equal across all the corresponding angles across the parallel lines will be the same. That is, this angle and this angle will be the same. Similarly, this angle and this angle will be the same. That is, angle XPQ is equal to PRS is equal to RTU. Let us now look at the next slide. Interior angles on the side of the transversal are supplementary. That is, PQS plus QSR is equal to 180 degrees. Let us go ahead. PQS plus QSR. That is also quite evident. That is, this angle and this angle, both of them will sum up to 180 degrees. Exterior angles on the same side of the transversal are also supplementary. That is, MQB plus DSU is equal to 180 degrees. MQB plus DSU. So it is basically saying that this angle plus this angle will be equal to 180 degrees. These are just formulas which will be useful if you are comfortable with it. But otherwise, if you just know that the corresponding angles across the parallel lines are the same, all of these corollaries can be easily deduced. So you need not worry if you are forgetting some of these formulas. If you understand the concept that a single line which is intersecting many parallel lines will make equal angles, then most of the questions can be answered. Transversals are cut by 3 parallel lines in the same ratio. That is, PR by RT is equal to QS by SU. PR by RT is equal to. This also is a very important formula. So the ratio of these two lengths, these two line segments, PR by RT, will be the same as QS by SU. Because two transversals, if they are intersecting the same set of parallel lines, the lengths of the line segments so formed will be in the same ratio. That is, PR and RT and QS and SU. The ratio of these two will be the same. Interior angles on the side of this transversal are supplementary. That is fine. Even this should be fine. Let us now look at the next slide. Now we go to triangles. After circles, the most important aspect of geometry is triangles. One of the things that many people know is that the sum of the angles of a triangle, they sum up to 180 degrees. If you have 3 sides and 3 angles, the sum of these 3 angles will be 180 degrees in any triangle. Another important concept with respect to triangles is if you have the lengths of the sides as A, B and C, and let us assume that C is the longest side, then the sum of A plus B will always be greater than C. The longest side is less than the sum of the shorter 2 sides. That is a very important property of any triangle. An angle less than 90 degrees is called acute and obtuse. This is also quite well known. But if you are having an acute angle triangle, if you are having A, B and C such that C is the largest side, another important aspect of acute angle triangles is that C square, that is the square of C, will be less than A square plus B square. C is the longest side. This is true for acute angle triangles where all the angles are less than 90 degrees. If it is a right angle triangle where one of the angles is equal to 90 degrees, then this becomes equal to C square, that is the longest side is the hypotenuse, is equal to A square plus B square. This is true in right angle triangles. If you are looking at obtuse angle triangles where one of the angles is greater than 90 degrees, then the square of the longest side, C square, is greater than A square plus B square. Note that even in an obtuse angle triangle, the longest side C will be less than A plus B. But the square of C in an obtuse angle triangle will be greater than A square plus B square. In a right angle triangle, it will be equal. This is called the Pythagoras theorem. And in an acute angle triangle, it will be less. Now let us look at the next slide. We have already discussed what is acute angle triangle, what is obtuse angle triangle, right angle triangle. And also another easy formula is that if you have a triangle and if you are extending one of the sides further, you are going to get an exterior angle. this angle will be the sum of the remaining two interior angles. If this is A and if this is B, then this exterior angle will be equal to A plus B. Let us now look at the next slide. Now we have important lines which are inside a triangle. If you have a triangle, if you are assuming that this triangle is A, B and C, if you are joining A, that is a vertex, to the midpoint of B and C, if this is equal to D, then this is called a median. If you are drawing the three medians, that is from C, if you are connecting to the midpoint of AB, and from B if you are connecting it to the midpoint of AC, then these three lines will be concurrent. They will intersect at the centroid. Another important theorem with respect to this is that if the centroid is G, then it divides each of the median in the ratio 2:1. That is AG divided by GD will be equal to 2:1. This is true for all the three medians. This will be 2 and this will be 1. This is the centroid. Similarly, if you are drawing a perpendicular line from the vertex A, B and C to the line BC, this is called the altitude. All the altitudes are also concurrent. Similarly, all the angle bisectors are also concurrent. All the angle bisectors meet at the incenter, and you also have perpendicular bisectors. So if you have a triangle for this side BC, you find out the midpoint, suppose it is D over here, and you draw a line which is perpendicular to BC. It need not go through A, but it will be perpendicular to BC and it will go through the midpoint of B and C. Similarly, if you are drawing the perpendicular bisector of AC and the perpendicular bisector of AB, all three of them will also intersect, and that point is called the circumcenter. Circumcenter and incenter are also important points in a triangle, because circumradius and inradius can be used to calculate the area of a triangle. Circumradius is the length from any vertex to the circumcenter, and inradius is the distance from any side to the incenter. That is, if you are having a triangle like this, if this point over here is the circumcenter, and if you draw a triangle, if you draw a circle where the radius of the circle is equal to the circumradius, then it passes through all the three vertices of the triangle. That is the important property of circumcenter and circumradius. Similarly, if you have a triangle and if this is the circle which is inscribed within the triangle, the center of that circle will be the incenter, and the radius of this triangle will be the inradius. That is another important property of inradius. Inradius will always be less than the circumradius. Now all of this, that is altitude, perpendicular bisector, median, all of this will coincide in an equilateral triangle. That is again a important formula or an important theorem. Let us now look at the next tip. The point of intersection of the three altitudes is called the orthocenter. This we have already discussed. And point of intersection of the three medians is called the centroid. And also with the centroid, remember the 2:1 theorem that we discussed earlier. A centroid divides each of the three medians in the ratio of 2:1. Three perpendicular bisectors intersect at circumcenter, and a circle drawn from this point would pass through all the vertices of the triangle. This we already discussed. Similarly, we have the incenter. From the incenter, if you draw a circle whose radius is equal to the inradius, it will touch each of the sides. Let us now look at the next question. Pythagoras theorem, I think we have already discussed. Similarly, Apollonius theorem also is an important theorem which will help us in finding out the length of the median of a triangle. Apollonius theorem basically looks at the three sides. Let us assume that this is the triangle A, B and C. This is A, this is B and this is C. Let us assume that the length of the side opposite C will be small c. Let us assume that the length of the side opposite B will be small b. Then we can calculate the length of the median from A to BC. Let us assume that length is equal to m, and let the length of BD be equal to x and the length of DC be equal to x. Basically, the value of A, that is the side which is opposite angle A, is equal to 2x. Then Apollonius theorem says that B square plus C square is equal to 2 times m square plus x square. or AC square plus AB square is equal to 2 times AD square plus BD square. So C square plus B square will be 2 times M square, that is the length of the median, plus X square, that is half the length of the other side. Now most cases you will be given the lengths of the 3 sides of the triangle and you are asked to calculate the length of a median. You can easily substitute them in A, B and C and calculate the value of M. This is the Apollonius theorem. Let us look at the next question. Midpoint theorem is again another very important theorem in triangles. It says that if you have a triangle, let us assume that this is A, B and C, and if you join the midpoints of any 2 sides, if you draw a line joining the midpoints of any 2 sides, this line will be parallel to the third side and it will be of exactly half the length of the third side. That is, if the length of BC is equal to small a, the length of this one, say DE, will be equal to A divided by 2. This is the midpoint theorem. Basic proportionality theorem is just an extension of the midpoint theorem. It says that if you are drawing a line which is parallel to the third side. So you are drawing a line, you have a triangle ABC, you are drawing a line which is parallel to the third side BC, then it is going to cut both of these sides in proportion. That is, if this is A and if this is D and this is E, if you are told that DE is parallel to BC, then it would imply that AD divided by DB. This is the ratio in which the parallel line intersects the line AB is equal to AE divided by EC. This is the basic proportionality theorem. This is just an extension of the midpoint theorem. Let us now look at the next slide. Interior angle bisector theorem is also a fairly important theorem. Interior angle bisector theorem says that if you have a triangle and if you have an angle bisector, it is going to divide the opposite side in the ratio of the remaining 2 sides. That is, if you have this to be the angle bisector, if this is X and this is Y, and if this is A and if this is B, then it would imply that X divided by Y, that is the ratio in which the angle bisector, the internal angle bisector is dividing the opposite side, is equal to A divided by B. Similarly, even external angular bisector theorem is also important. It is also fairly similar. You can look at it. At this point, I would like to say that we are giving 3 mock tests for CAT completely free. If you are looking to take the mock test, please go to this link cracku.in/cat mock test and you can find the 3 mock tests along with video solutions completely for free. If you are not sure how to actually find this page, you just go to Google and in Google you just type Cracku free. You can actually see even Google is suggesting that Cracku free cat mocks. Let me just do backspace because it is Cracku free space cat mocks. Yeah. You can see that there are many people who are actually advertising for this, but you can go here and you will end up with the same page. This is going to have 3 mocks. If you are looking for only sectionals, if you are looking for free sectionals, for example, you can go to the mocks and below mocks you can find cat sectionals. You can go to any one of these sectionals. So you can go to quant sectional, there will be one sectional for free which has video solution. Similarly, you can even go to the verbal and LRDI sectionals. Especially I would recommend you to take as many LRDI sectionals as possible. So the first LRDI sectional is actually completely free. It also has video solutions, so you should definitely check it out. Let us now look at the next slide. Cyclic quadrilateral, many questions are actually asked in cyclic quadrilateral. If you have a circle and if you are joining any 4 points on the circle, you are going to get a cyclic quadrilateral. The key property of a cyclic quadrilateral is that the sum of the adjacent sides, the sum of the opposite sides will be equal to 180 degrees. So if this is A and if this is B, then A plus B will be equal to 180 degrees. That is a key property of a cyclic quadrilateral. If you know the lengths of the sides of the cyclic quadrilateral, you can actually calculate the area of the cyclic quadrilateral. Sum of you calculate the semi-perimeter of the cyclic quadrilateral, which is A plus B plus C by C plus D by 2, and then you can calculate the quadrilateral. This formula is actually invented or discovered by Brahmagupta, who is an ancient Indian mathematician. Now exterior angle is equal to the remote opposite angle, again is something that you can easily derive. Let us now look at the next slide. Now given an equilateral triangle, you can calculate its length, its area, its altitude, its in radius and its circumradius. It is a good thing for you to actually remember these things, remember these formulas on your own, especially the area of the equilateral triangle. If you have an equilateral triangle and if each side of the equilateral triangle is x, then the area of the equilateral triangle is root 3 by 4 x square. That is the area of the equilateral triangle, and the altitude, that is the length of the perpendicular drawn from one vertex to the opposite side, this will be equal to root 3 by 2 into x. This also can be very easily derived, so there is not much need for you to remember or mug up these formulas if you have the confidence that you can remember them. Another important aspect in an equilateral triangle is that the in radius, small r, will be equal to the circumradius divided by 2, and the in radius is 1/3 the altitude. That is, it is actually equal to x divided by 2 root 3. This is the, if x is the side of an equilateral triangle, that is the in radius, and the circumradius will be x divided by root 3, which is twice the in radius. Similarly, you can calculate the area of an isosceles triangle. Again, this formula is not necessary for you to mug it up. If you can derive it, it is all the better. A key topic or a key concept in geometry is that of similar triangles. If you have two triangles which look the same by proportion but are of different sizes, they are called similar triangles. We can actually define similar triangles as triangles where all the angles are exactly the same. That is, each of the angles A, B and C across both of these triangles are the same. Those are called similar triangles. And the important property of similar triangles is that all of their angles will be the same and all of their sides will be in exactly the same proportion. That is, the length of the first side to that of the second side, if you assume that this is A, this is B and this is C, capital A, capital B, capital C, and if this is small a, small b and small c, if these two triangles are similar, then capital A divided by small a will be equal to capital B divided by small b will be equal to capital C divided by small c. And how do you know if they are similar triangles? There are many ways in which you can figure it out. If two angles are the same in a pair of triangles, automatically the third angle will be the same because the sum of the angles of a triangle is equal to 180 degrees. So we can infer that they are similar triangles and therefore their sides will be in proportion. Or if you know that all the three sides are in proportion, even then you can infer that they are similar triangles and therefore all of their angles will be the same. Or if you are told that there are two sides which are in the same proportion and the angle which is joined by them, that is the angle which is enclosed between these two sides, then also they are similar triangles. That is, you have two triangles like this. This side and this side, the ratio is the same as this sides and this sides. And we are also told that the angle between them is the same. Then both of these triangles are similar triangles. Let us now go to the next slide. A concept which is very closely related to similar triangles is that of congruent triangles. Here two triangles are said to be congruent if they are exactly the same. That is, all the three sides are the same and all the three angles are the same. How can we determine if two triangles are congruent? If we can figure out that all the three sides are exactly the same as each other, then both the triangles will be congruent. Or if we can figure out that there are two sides which are the same and the angle enclosed within them is also the same, then even then they are congruent triangles. We can then infer that the remaining two sides, the remaining two angles and the side will also be the same. Now the key aspect over here is we should get two sides and the angle enclosed between them. It should not be any other angle. Similarly, if you are getting two angles to be the same, that is, you have one triangle over here and another triangle over here, you have figured out that this angle is equal to this angle and this angle is equal to this angle and the side which is enclosed between them is also same. Then also both the triangles will be congruent. So this is basically the SSS property, that is, all the three sides are exactly the same, or two sides and the angle enclosed between them is the same, or two angles and the side enclosed between them is the same, or two angles and any other side is also the same. The key aspect over here is if two angles are the same, the third angle will also be the same because the sum of the angles of a triangle is always equal to 180 degrees. So if these two angles are the same as these two angles, then the third angle will also be the same, because it will be 180 degrees minus the sum of the remaining two angles. So if you get two angles to be the same and the corresponding side to be the same, then also they are congruent triangles. Let us now look at the next slide. Once we are given the lengths of the three sides of a triangle, we can easily calculate the area of the triangle. We first calculate the semi-perimeter, which is equal to a plus b plus c by 2, and then we can use this formula to calculate the area. Another way of calculating the area is half into base into height. So if you have a triangle, first find out the height of the triangle, that is, draw a perpendicular from one of the vertex to the other side, and this will be the base, this will be the height. Half into base into height is the area of a triangle. Similarly, it is equal to half into AB into sin C. That is, if you know the lengths of two sides and the angle enclosed between them, then just multiply the product of the two sides with the sine of the angle enclosed within them and multiply this with half. So this is half into AB into sin C, where C is the angle between A and B. Or if you know the circumradius, the area is equal to A into B into C divided by 4 times the circumradius of the triangle. This question was actually asked once. This formula was supposed to be used in one of the questions in CAT 2021. Or I think it is CAT 2020. Or if you know the in center, then A is equal to R into S, where S is the semi-perimeter and R is the in radius. So all of these formulas can be used and you are going to get the same area. Let us now look at the next question. There are some special triangles which have 30, 60 and 90 degrees or 45, 45, 90 degrees. This is an isosceles right angle triangle. This is a very commonly seen right angle triangle. You can calculate the lengths of each of the three sides if you know one of the side. Next is with respect to an in center. This is an extension of the theorem which says that if you have a circle and from one point, if you are drawing two tangents to the circle, if this is one tangent and if this is another tangent, then the lengths of both of these tangents will be the same. If you are drawing two tangents to a circle from any particular point outside the triangle, the lengths of both the tangents will be the same. Now you know that if you are drawing the in circle is going to touch all the three sides. So you can easily figure out that CP will be equal to CR, because CP and CR are tangents to the in circle from the point C. Similarly, AP will be equal to AQ, because from A the two tangents to the circle are AP and AQ. Similarly, BQ will be equal to BR, because there are two tangents from the same point B. We have already figured out the circumradius and the inradius of an equilateral triangle. Let us go to the next slide. Now, an extension of this is that if you have a circle and if you have the diameter of the circle, if you connect both the ends of a diameter of the circle to any point on the circumference, this angle will always be equal to 90 degrees. So the angle subtended by a diameter of the circle is always equal to 90 degrees. Similarly, angles subtended by equal chords are equal. That is, if you have a circle over here, this is one chord and this is another chord. If the lengths of both the chords are the same, then this angle subtended by them at the center, this angle will be the same as this angle. Equal chords, they subtend equal angles at the center of the circle. Equal chords are also equidistant from the center. That is, if you have a circle and if this is one chord, this is the distance of the chord from the center. If this is another chord of equal length, then the distance of the chord from the center will be exactly the same. The radius from the center to the point where the tangent touches the circle is perpendicular to the tangent. This is again a very useful theorem. This is used in many of the problems. If you have a circle and if you have a tangent to the circle, say this is a tangent which touches the circle at exactly one point. If you connect that point to the center of the circle, if say this is the center of the circle, these two lines will be perpendicular to each other. The tangent is perpendicular to the point connecting the point of intersection of the tangent and the circle to the center. Tangents drawn from the same point of a circle are equal in length. This we have already discussed. A perpendicular drawn from the center to any chord bisects the chord. So if you have a circle and if there is a chord, if this is the center of the circle, if you draw a perpendicular from the center to this particular chord, it is going to bisect the chord. any chord, if you are drawing a perpendicular from the center of the circle to that chord, will touch the chord at the midpoint. Now, if you are given a circle and if you are asked to calculate the area of the sector, this area over here is theta divided by 360 times the area of the triangle, because the area subtended at the center is theta, the area around the point, that is the area around the center, is 360 degrees. So the area of the sector will be theta divided by 360 into pi r square. To calculate the area of the minor segment, that is to calculate this area, we have to subtract the area of the triangle from the area of the sector. The area of the triangle is again using our earlier formula of half into a into b into sine c. This will be half into the radius is r, so r into sine theta. So it is theta divided by 360 into pi r square minus r square by 2 into sine theta, which is the area of the triangle OAC. Then you are going to get the area of the minor segment. Let us now look at the next question. Inscribed angle theorem is a very simple theorem. It says that the angle subtended at the circumference is half the angle subtended at the center. So if this angle over here is equal to x, the angle subtended at the center will be equal to 2x. This is true for any chord. Angle at the circumference will be half the angle at the center. A related theorem, actually a theorem which will be again very useful, is if you are looking at any chord or any sector, the angle subtended at the circumference will be the same. In this case, A will be equal to B. So you have a circle and this is the chord that you are looking at, or this is the sector. You connect these 2 points to any point on the circumference. This angle will be the same as this angle. A related theorem is that of the alternate segment theorem, which says that if you have a circle and you have a tangent to the circle, let us assume that this is the tangent to a circle. The point of intersection is over here and this is connected to any point on the circle. Let us assume that this is A and this is B and this is the tangent T. Let us assume that this angle over here is say x. Now the chord AB subtends the same angle at any point on the circumference. You join both of them to any point on the circumference. This angle will be x, because AB, if you join them at any other point on the circumference also, like we have discussed earlier, that also will be x. This is called this is a very important theorem, alternate segment theorem. Let us look at the next question, next slide. This is the tangent secant theorem, which says that if you have a circle and from a particular point, if you are drawing 2 secants, then the length of this, if you are assuming that this is A, B, C, D and E, the length of AB into AC will be equal to the length of AD into AE. This is the tangent secant theorem. An extension to this is if you make a tangent over here, if say the tangent touches this at point F, this will be equal to AF whole square, because at the extreme when both B and C keep coming close to each other such that the line segment AC, instead of being a secant, if it is becoming a tangent, then the length of AF will be very close to the length of AB and AC as they are coming outside the circle. Anyway, if you are not understanding it, just ignore it. Know that AB into AC will be equal to AD into AE, which will be equal to the length of the tangent AF whole square. We have a very active Telegram group. We have close to 12,000 people who are very active in the Telegram group. They ask a lot of important questions. They answer many questions. We also participate in the Telegram group quite often. So if you have the Telegram app installed, you should definitely join this Telegram channel. Let us now look at the next slide. In this slide, we can, using this formula, you can calculate the lengths of the direct common tangent of 2 circles. And using the next formula, you can calculate the length of the transverse common tangent of 2 circles. In my opinion, these formulas are not super important, but if you have time, you can definitely check them out. In this slide, we know that if there is a polygon such that all the sides are the same or all the angles are the same, it is called a regular polygon. And the number of diagonals of any polygon, if it is an n-sided polygon, the number of diagonals will be n into n minus 3 divided by 2. This is an important formula. This formula is often asked in permutations and combinations. So this is a formula that you should remember. Another theoretical question is that the sum of all the exterior angles of a polygon is 360 degrees. The sum of all the interior angles of an n-sided polygon is 180 into n minus 2. Therefore, if it is a regular polygon where all the sides are the same or all the angles are the same, each exterior angle will be equal to 360 divided by n. And each interior angle will be equal to 180 into n minus 2 divided by n. Let us now look at the next slide. Here we have a hexagon. What is the number of diagonals of a hexagon? It will be 6 into 3 divided by 2, which is equal to 9. So there are 9 diagonals. And what is the sum of the exterior angles of a hexagon? The sum of the exterior angles will remain the same. It will be 360 degrees for any value of n. Therefore, each exterior angle, because there are 6 sides of a hexagon, regular hexagon, will be 360 by 6, which is 60 degrees. What is the sum of the interior angles of a regular hexagon? That will be 180 into n minus 2, that is 6 minus 2, which is 4. This is equal to 720 degrees. Because there are 6 sides, each of the interior angles will be 720 divided by 6, which is 120 degrees. The area of a regular hexagon, again an important formula, is 3 into root 3 by 2 a square. You can again derive this quite easily, but it is good to remember this. Here we have the formula for the volume of different solids. Definitely remember all of them. They are very useful, and many times you will get a direct question from this. So this is part of the mensuration. So definitely check it out. This is for the total surface area of different solids. Very important. Again, definitely go through all of them. Total surface area, lateral surface area, curved surface area, all of them are important. These 3 slides, I would recommend you to remember all of these formulas. I think this we have already discussed. This is very similar to what we have discussed earlier. So this ends the part of formulas and concepts. If you have any doubts with any of these formulas, and if you want us to explain it in detail, feel free to comment below this video. We will definitely check it out. And now comes the important part. Remember that in geometry, knowing the formula is one thing, but applying it is of equal importance, in fact of more importance. We have given you around 55 questions or 56 questions with detailed solutions. Let us go through them and I'll explain how you can actually use it very well. So as we discussed earlier, the important aspect of geometry is not just learning the formulas, but applying the formulas. We have given around 56 questions in this PDF. Definitely go through each one of them. All of these questions even have detailed video solutions. So you can go through this question. It might not be legible here, but if you download the PDF, then you can see the question, try to answer it on your own. If you're not able to get it, then we have given a detailed explanation. Go through the text solution, and if you're not able to understand the text solution, you can find a blue button under every question. So click on the blue button, you'll go to our website, and in the website you'll see the same question with the text solution, and below the text solution you'll see the video solution. In order to actually view the video solution, you'll have to create an account. The account is free, you don't need to pay anything, but definitely create an account if you're looking for the video solutions. So all of these 56 questions have detailed video solutions on our website also. Try to understand them, and I'm sure this will benefit you quite a lot. If you're finding this video useful, if you're finding the capsule, the geometry capsule useful, and if you want us to create these kind of capsules more often, please do share this video, please do share this PDF, especially with all of your friends. It will help us reach more people, and if more people are using our free materials, we will be motivated to do these kind of videos more often. Please do like this stream, and please do comment your doubts below the video.